Good morning, guys. All of you, welcome to Ashok IT. So, my name is Ashok. Today, we are here to understand one very important topic for Java developers, that is Java microservices development. We are going to understand what is microservice and how to develop a application by using microservices architecture. So this is 2 days workshop, guys. Today and tomorrow also we are having the session. As part of this 2 days session, what we are going to learn, what is our agenda. So as part of this session, we are going to learn first what is monolithic architecture, what is monolithic architecture, and what are the challenges available with the monolithic architecture. Then we are going to understand what is microservices architecture and why microservices architecture came into market, and what are the advantages available with the microservices architecture. What is monolithic architecture and what are the challenges available with the monolithic architecture. Then we are going to understand what is microservices architecture and what are the challenges available with the microservices and what are the advantages with the microservices. Then we are going to learn about service registry. What is the meaning of service registry? Some people also call it as a discovery server. So in the real time, some people also call this as discovery server or discovery service. Service registry or discovery service, both are same. Then we are going to understand admin server. What is Spring Boot admin server and why we need to work with that admin server. Then we are going to understand what is Zipkin server in the microservices. What is the meaning of Zipkin server and why we need to use that Zipkin server and how to work with the Zipkin server. Then we are going to understand APIs development, REST APIs development, how we are going to develop our backend REST APIs by using Spring Boot. And when we are developing backend REST APIs, how to establish inter-service communication among those APIs. What is inter-service communication? What is inter-service communication? How to establish that inter-service communication by using Feign client. Okay, then next one, we are going to understand what is API gateway, which is used to perform pre-processing of a request. Inside this API gateway, we are going to understand routings and filters, how to route the request from the API gateway to the backend services. API gateway is going to act as a mediator between the incoming request and the backend APIs. So how to implement routings in the API gateway, how to implement filters in the API gateway, we are going to understand. After this, we are going to discuss one more important concept here, that is cloud config server. We are going to understand one more concept called cloud config server, and based on all these topics, we are going to develop one mini project also. By using all these concepts, we are going to develop one mini project also. This is the agenda for today and tomorrow session. Java microservices development. So in order to understand Java microservices development, you need to know what is monolithic architecture and what are the drawbacks available in the monolithic architecture, and why microservices came into picture, what is microservices architecture, what are the advantages available with the microservices architecture, and how people will develop the microservices in the real-time project. So what is service registry, what is the role of service registry in the microservices development, then what is admin server, what is Zipkin server, what is the role of admin server, what is the role of Zipkin server, and APIs development. These are our backend microservices. We are going to develop 2-3 microservices in the backend, and we are going to establish inter-service communication for those microservices by using Feign client concept. Okay, then we are going to understand what is API gateway. API gateway basically used to is used to perform the pre-processing of the request. Okay, the routings and filters we are going to implement by using API gateway, and we are going to understand what is cloud config server, and we are going to understand one mini project development by using all these concepts. Okay, this session is going to be there for 2 days of time. Today and tomorrow also we have this session, and for this session there is no fee. It is completely free of cost. And whatever the notes I am preparing, class notes and class video also, I'm going to share with you people after the session got completed. So where I'm going to share these notes and video, I'm going to share these notes and video in our WhatsApp channel. I'm going to share this in the WhatsApp channel. The WhatsApp channel link already I have given in the chat box. The WhatsApp channel link I have given in the chat box. So just click on that link and follow us in that WhatsApp channel. Then you will get the class notes and class video also after this class is completed. So class is there today and tomorrow also. Okay, so the session is there for 2 days. The session duration 2 days. Okay, today and tomorrow. Today and tomorrow the class is available. Session timings, it is from 8 a.m. to 10:30 a.m. IST. Today and tomorrow same timings we are going to follow. The class will be there from 8 a.m. to 10:30 a.m. IST. 2 days workshop. In these 2 days of time we are going to learn all these concepts, and we are going to implement one project also. Okay, good. So class notes plus class videos will be shared in Ashok IT WhatsApp channel. So the channel link I have already shared in the chat box. Follow us in WhatsApp channel in order to get the details. Okay, the channel link I have shared in the chat box. So please follow us in the channel so that you are going to get all the updates. Are you able to access the channel, guys? Are you able to access the channel now? Come on. Please confirm. You got the clarity? You got the clarity on the agenda, what we are going to learn, what topics we are going to learn, and how many days we are going to learn, and what are the timings of our class, and how to get the class notes and class video for this workshop. If it is clear for all of you, please type in the chat box, clear for us. If it is clear for you, please type in the chat box, it is clear for us. Come on. Is it clear for everybody? I'm not getting confirmation in the chat box. I'm not getting the confirmation in the chat box. All of you, please confirm in the chat box if it is clear for you. Come on, guys, respond quickly. Respond quickly. Good, fine. Okay, let's get started, guys. So the first thing that we are going to understand, what is monolithic architecture? What is monolithic architecture? So if you look at this diagram, what is monolithic architecture? Earlier, when we are going to develop the projects, a project will contain several functionalities. If you develop all the functionalities in one single application, then it is called as monolithic architecture. So what is the meaning of monolithic architecture. Monolithic architecture is nothing but developing all the functionalities in one single application, single unit, developing all functionalities as single unit. So a project can contain n number of functionalities. If you take one banking application, in the banking application, credit card system will be available, debit card system will be available, net banking will be available, mobile banking will be available, loans, gold loans, educational loans, personal loans, like that. Several functionalities will be available in one application. Okay, application can be developed in two ways, guys. So if you take any project in the real time, application can be developed. Application can be developed in two ways. What are those two ways? One is by using monolithic architecture. One of the architecture that people will follow, that is monolithic architecture. That was the old approach. Nowadays in the market, people are developing the application by using microservices architecture. So a project can be developed in two ways, guys. One is by using monolithic architecture and another one is by using microservices architecture. So do you have any idea on monolithic architecture and microservices architecture, guys? Anybody having any idea about monolithic architecture and microservices architecture? Can you please respond in the chat box? Do you have any idea on the monolithic architecture and microservices architecture? Come on, could you please tell me that? Do you have any idea on the monolithic architecture and microservices architecture? Come on, could you please confirm any idea on the monolithic architecture and microservices architecture? So in the real time, application can be developed in two ways, guys. In the real time, application can be developed in two ways. What are the two ways to develop our application? One is by using monolithic architecture, another one is by using microservices architecture. A project can be developed in two ways. One is by using monolithic architecture, another one is by using microservices architecture. What is the meaning of monolithic architecture? Develop all the functionalities, in single application. If you develop all the functionalities in one single application, then that application is called as monolithic architecture application, single unit. For example, in my application, net banking is available, net banking functionality is available, mobile banking functionality is available, credit card functionality is available, debit card functionality is available, okay, educational loans available, property loans available, and mortgage loans available, gold loans available. So there are n number of functionalities available in our application. If you develop all these functionalities as one single project, then that project is called as monolithic architecture based project. So can you read this point? What is the meaning of monolithic architecture? A monolithic architecture is a software design pattern where all components of a system are integrated into single unified application. So a project nothing but collection of requirements will be available, several functionalities will be available. If you develop all those functionalities in one single application, then that application is called as monolithic architecture. So if you develop your project by using monolithic architecture, there are some challenges available. What are the challenges available with the monolithic architecture? Problems with the monolithic architecture. What are the problems available? The first problem, tightly coupling, because everything is available at one place. So the project will have tightly coupling problem. So the project is going to have tight coupling is available. Tightly coupling. So if you want to change any small functionality, then it may impact on the other functionalities, because everything is available at one place. If you make a minor change in a project, that may affect on the some other functionality, because several functionalities we developed in one single application. If you make a minor change in the application, if you make a small change in the credit card functionality, okay, so credit card functionality available, debit card functionality, loans functionality, net banking available, mobile banking is available. All the functionalities are developed as one project, so many classes are available. If you make a modification in the existing functionality, in one functionality, if you make a modification, it may impact on the other functionality. So that is the reason when you go for monolithic architecture development, the project functionalities are tightly coupled. The project functionalities are tightly coupled. Because of this tightly coupling, maintenance is difficult. The project maintenance is going to be very difficult when you implement that project by using monolithic architecture. If you want to make a minor change in the application, it may impact on the some other functionality. If you make a minor change in the application, it may impact on the some other functionality also. If you make a minor change in the application, it may impact on the some other functionality also. Maintenance of the project is going to be difficult. And what is the another problem? The another problem is redeploy entire application. The another problem, redeploy entire application. If you make a small change in the application, then you need to redeploy the entire project. I made a minor change to the credit card functionality. If you make a minor change to the credit card functionality, you need to redeploy the entire application here. You need to redeploy entire application. So the deployment risks will be available. Okay, first problem with the monolithic, the project is tightly coupled. Everything we developed at one place. Then as everything available at one place, the maintenance of the project is going to be difficult, and we need to redeploy the entire application. And the next one, this project is technology dependent. The project is technology dependent. So that means if you develop your application by using Java, then all the functionalities you need to develop by using only Java. So you can't use different technologies to develop one project. So it is a single project. Everything we are developing in the single project. So we need to choose only one technology. The project is technology dependent. The project is technology dependent. And here, as we are developing everything in the single application, burden on the server. Burden on server. Because credit card functionality, debit card functionality, net banking, loans, gold loans, personal loan, educational loan, mortgage loan, property loan, everything is available in one project which is deployed in the server. So when everything is available in the server, so many people, some people are accessing credit card, some people are accessing debit card, some people are accessing net banking, some people mobile banking, some people loans. So many customers are using our application at a time. If so many customers are using our application at a time, all the requests will go to single application. That application is available in the single server, then burden will be increased on the server. Burden on the server, it can cause server crash also. It can cause server crash also. Our server can be crashed and users may not be able to get the response as expected. The response of the application will become very slow because the burden is increasing on the server. So earlier, long back, people used to develop the application by using monolithic architecture. What is the meaning of monolithic architecture? Develop all the functionalities, developing all the functionalities in one single application, functionalities in single application, single unit. Everything is available at one place only. We are developing as one single project. So many requirements are available. All the requirements, if you develop in one application, then it is called as monolithic architecture based application. If you develop all the application, all the functionalities as a single application, then it is called as monolithic architecture. So if you go for monolithic architecture, then what are the problems available? So there are several problems available with the monolithic architecture. What are those problems, guys? So the project is tightly coupled because all the functionalities available at one place, and the project maintenance is going to be difficult. The project maintenance is going to be difficult, And if you make a minor change in the application, you need to redeploy the entire application. And so suppose I made a minor change to the credit card functionality, then you need to redeploy the entire project in the server. It is a time-taking process. And if you choose one technology to develop the project, you need to stick to that technology only. The project is technology dependent, and as everything is available at one place, the burden will be increased on the server. Server can crash. Server can crash. So are you guys able to understand what is monolithic architecture and what are the challenges available with the monolithic architecture? Are you able to get the clarity? Are you able to get the clarity on what is monolithic architecture and what are the challenges available with the monolithic architecture, guys? What is a monolithic architecture and what are the challenges available with the monolithic architecture? If you are able to get the clarity, then could you please confirm in the chat box, I am clear. I need your response. Please make the session is more interactive. If you are responding to the session, then I will get more interest, guys. If you are responding to the session, then I will get more interest to deliver the subject. If you are not responding, then I will also lose my interest. Are you able to understand? Earlier in the industry, earlier in the software industry, companies used to develop the project, right? So the project can be developed in the two ways. In the earlier software industry, used to develop the project by using monolithic architecture. What is that monolithic architecture? If you develop all the functionalities as one single application, which is called monolithic architecture. So your presentation logic, your business logic, data access logic, everything will be available at one place. User interface, business layer, data access layer, everything available at one place, which is called monolithic architecture. When you go for that monolithic architecture, there are some challenges available. What are the challenges available? Project is tightly coupled, all the functionalities at one place. So the project is tightly coupled. The maintenance of the project will become very difficult, because if you want to make a minor change, it may impact on the some other functionality. If you make some modifications to one class method, it may impact on the other functionalities. So you need to be very careful when you want to make some changes in the project. And the next one, deployment risk. If for a minor change, we need to redeploy the entire application. Okay. And scalability issues. I want to scale up one functionality because so many requests are coming to the mobile banking. I want to scale up the mobile banking functionality. So that's not possible. If you want to go for the scaling, you need to scale up the entire functionality. Particular functionality you can't scale up, you can't scale down, because everything is available as one unit. Everything is developed at one place. Okay. Then as all the functionalities available in one server, when they are deployed, that project is deployed in the server, that server will get so many requests, then burden will be increased on the server. When burden is increased on the server, server can crash. When burden is increased on the server, server can crash. Okay. So these are the challenges available in the monolithic architecture, guys. So to overcome the problems of this monolithic architecture, people started using microservices architecture. To overcome the problems of monolithic architecture, people started using microservices architecture. Sir, what is the meaning of microservices and what are the benefits available with the microservices? The very first thing that you need to understand, microservices is not a technology like Java, not a technology like a Python, not a technology like a .NET. The first thing that you need to understand, microservices is not a technology. First thing that you need to understand, microservices is not a technology. And the next thing, microservices is not a framework. We have a Spring Boot framework, we have a Hibernate framework, we have a Python people having Django framework, like this. But microservices is not a technology. Microservices is not a framework, and microservices is not an API also. Sir, we have JDBC API to communicate with the database. We have Servlet API to develop web application. We have Jackson API to convert Java object to JSON, JSON to Java object. But here, microservices is not API. Microservices is not a programming language. Microservices is not a framework. Microservices is not a technology, or microservices is not a language. It is not a language. It is not a framework. It is not API. Then what is microservices? Microservices nothing but it is one design pattern. Microservices is called architectural design pattern. So earlier companies used to develop the application by using monolithic architecture. So they realized that if we develop the project by using monolithic architecture, there are several challenges available, guys. If we develop the project by using monolithic architecture, there are so many challenges available. So many challenges available. What are those challenges? We have already seen. Tightly coupling is one challenge. Maintenance is one challenge. Okay. Burden on the server. Redeploying the application. Technology dependent. So there are several challenges available when you go for monolithic architecture. So to overcome the problems of this monolithic architecture, people are using microservices architecture. Okay, what is this microservice? Microservice is not a technology. It is not a language. Microservices is not a framework. Microservices is not an API. What is microservice then? Microservice is called architectural design pattern. Microservice is called as architectural design pattern. Okay, this design pattern is a universal design pattern. Anyone can use this design pattern to develop their application. These microservices not only for Java, not only for Python, not only for .NET. Java developers can use this microservices design pattern to develop the application. .NET people can use this design pattern to develop the application. Python people can follow this design pattern to develop the application. So microservices is an architectural design pattern. Anybody can use, any programming language developer, any technology developer can use this microservices design pattern to develop their applications. Okay, earlier people used to develop the project by using monolithic architecture. So there are some challenges available. To overcome the challenges of the monolithic architecture, people are going with the microservices architecture. Microservice is not a programming language. Microservice is not a framework. Microservice is not a API. Then what is microservice? Microservice nothing but a design pattern to develop our application. So our application contains several functionalities. So if you take e-commerce project, set of functionalities like product categories, product checkout, product payment, product order, order cancellation, order tracking, some functionalities are there. If you go for any traveling application like Make My Trip, yatra.com, redbus.com, GoIbibo, bus ticket booking, train ticket booking, flight ticket booking, hotel ticket booking, cab booking, several functionalities available. And if you go for insurance application, health insurance will be available, life insurance will be available, term policies will be available, savings will be available. Okay, so if you take any project, set of functionalities are available. So project nothing but set of requirements, set of functionalities available. If you develop all those functionalities, presentation layer, business layer, data access layer, everything as one single project, then that is called monolithic architecture. That is old style of development. If you go for a monolithic, only one project, everything is available in one project. So lot of problems. Tightly coupling, maintenance problem, technology dependent, redeployment required for entire project. And if you want to scale up one functionality, that's not possible. As everything available at one place, burden will be increased on the server. So people struggled a lot with the monolithic architecture based applications in the industry. That's why they want to come out of those problems. So to come out of those problems, what they are doing now? They are using microservices architecture. So what is the meaning of this microservices architecture? Microservice is not a technology. It is not a programming language. It is not a framework. It is not API. Then what is that? It is one design pattern which is used to develop our application. And who can use this design pattern to develop application? Only Java developers, only .NET, only Python. No, this is universal. Anybody can follow this microservices design pattern to develop their application. Okay, so if we develop our application by using microservices architecture, then what are the advantages available? So if we develop our application by using microservices architecture, then what are the advantages we are having? What are the benefits we are having if you develop our application by using microservices architecture? Can anybody guess what are the advantages available if you develop our application by using microservices architecture, guys? If we develop our application by using microservices architecture, what are the advantages available? Can you tell me? Can you type in chat box? What are the advantages available? What are the advantages available with the microservices architecture? Come on, guys, quickly respond. Wow, we reached almost 700 people for the workshop. I'm really shocked. I'm really surprised by seeing this count. Thank you so much, guys. So this is very good number. This is very good number. 700 plus people are attending this workshop. So this is 2 days workshop. So don't miss this 2 days workshop. As I told you, this is going to be very useful for you people. Okay. So all these topics are hot topics in the industry. If you are attending any interview as a Java developer, irrespective of your experience, whether you are a fresher, whether you are a experienced, whether you are a fresher, whether you are a experienced, all these concepts they are going to ask in the interview. All these concepts they are going to ask in the interview. Okay, good. So 2 days you need to attend this workshop and you are going to get the class notes and you will get the class video also. I will share that notes and video in our WhatsApp channel. WhatsApp channel link I am sharing in the Zoom chat box. Okay, Ashok IT WhatsApp channel link I am sharing in the chat box. So please follow us in that WhatsApp channel so that you no need to call the admin team. You no need to call the admin team for getting these notes and for getting this video. Okay, after the session is completed, I will upload that in our WhatsApp channel so that you can access it. You no need to follow up with the admin team for the notes and for the videos. So if you follow us in that WhatsApp channel, you will get everything. Okay, very good. Good. Next one. So we understood what is microservice. Microservice is a design pattern. It is used to develop our application. Okay, it is universal and anyone can use this architecture to develop their application, and it is not specific to particular technology, not only for Java, not only for .NET, not only for Python. Anybody can use this architecture to develop their application. So what are the advantages are available when you go for microservices architecture? So we have seen monolithic architecture, we have seen challenges of monolith. So to overcome the problems of the monolithic architecture, now we are going for microservices architecture. So what is this microservice architecture, guys? Microservices architecture is a design pattern. Can you read this point? Microservices architecture is a design pattern where an application is composed of multiple small independently deployable services that can communicate over a network. Could you please repeat that once again? Can you read that statement? If it is difficult to understand, I will simplify that. Can you please read that statement once? Can you read that statement once? Microservices architecture. So what is the meaning of that microservices? It is a design pattern to develop our application as a small units. So it is simple, divide and conquer. Don't develop everything at one place. Don't develop everything at one place. Divide your functionalities into small services. Instead of developing all the functionalities in one single application, you divide your functionalities into small services. That is called microservices architecture. Sir, what are the advantages available? What are the advantages available when you go with this microservices architecture? So the first advantage with the microservices, which is loosely coupled. So one functionality is loosely coupled with the another functionality. So here, if you take one example of Make My Trip application, let me show you one example of Make My Trip application. So if you go to Make My Trip application, in the Make My Trip application, lot of functionalities available. Train ticket booking is available, flight tickets booking is available, hotel booking available, bus booking, cabs booking available. So flight tickets, hotel tickets, holiday packages, trains, buses, cabs. So many functionalities available. If you develop all these functionalities in one project, monolithic. So to overcome that problem, what we are going to do? We are going to follow microservices architecture. So when we go for microservices architecture, what we are going to do here, guys? So here for a hotel booking, I'm going to develop one project, hotels booking. Hotels booking functionality will be available, that is developed as one project. Then similarly, we are having flights ticket booking. Okay, flights ticket booking, I'm going to develop as separate project, flights booking. Okay, similarly, we need to book the train tickets booking, trains booking is available. This one I'm going to develop as a separate project. So this is one microservice, this is one microservice, this is one microservice. All these microservices are belongs to one application. That application is called as make my trip application. So earlier everything is developed as one project. If you develop everything as one project, that is called monolith. There are some problems. To overcome those problems, we are going for microservices. What is the meaning of microservices? Don't develop everything in single project. Hotel ticket booking functionality, you develop a hotel tickets booking as one simple project. So this hotels booking project contains only the functionality to book the hotel tickets. That's it. Hotels booking will be available in that. So no other functionality. Hotels booking is developed as one separate project that is having a separate database. And similarly, flights booking, flight tickets booking. So develop one simple project which contains only the logic to book the flight tickets. For this, let us take a separate database. So this is one microservice. Microservice nothing but a simple project, a single project, a simple project or a small project which contains only one specific functionality. Similarly, train tickets booking I want to implement. For train tickets booking, develop one separate project. This is called one microservice. This is called one simple service. This will contain the logic only to book the train tickets. This will contain the logic to book only the train tickets. So like this, instead of developing all the three functionalities in one project, I'm developing three functionalities as three different projects. That is called microservices development. So earlier, everything is developed in single application. So long back in the IT industry, people used to develop the project. Now, if you take this project, suppose for example, so in this project, I'm writing the logic for hotels booking. Hotels booking is available in this project. Similarly, flights booking is also available and trains booking also available in the single project. Okay, all the three functionalities I have implemented in one project only, a single project. That is called monolithic architecture. Hotels booking available, flights booking available, train tickets booking available, and for this project, single database is also available. Hotel booking, flights booking, trains booking, everything implemented in the single project. That is called monolith. It will have a single database. That is having a single database. So if you develop your application like this, that is called monolithic architecture, the problems are available. So to overcome the problems of the monolithic architecture, we are going for microservices development. So when you go for microservices, what we are doing? Hotels booking, we are developing as one simple project. Flights booking, we are developing as one simple project. Trains booking, we are developing as one single project. Are you clear? What is the advantage now? Loosely coupling. So one project contains only hotels booking code. The code is available to book only hotels in one project. That is separate project. That project you can develop separately, you can test separately, you can deploy separately, you can execute separately. It is completely independent. It is completely independent. Similarly, flight tickets booking is required. We are going to develop a project, a simple project which contains only flights booking logic. That project you can develop, you can test, you can deploy, you can execute, you can deliver independently. A small service. Similarly, trains tickets booking is available. Create one simple project which contains only the logic to book the train tickets. Develop, test, deliver independently. Okay, and every microservice having its own database. And all these microservices are called as backend APIs. So every microservice is one REST API. Every microservice is one REST API. For these REST APIs, UI application will be available. One UI application will be available, and this UI application is going to communicate with all the backend APIs based on the demand. Hotels booking project is one API. It will run in one server. Train ticket booking API will run in separate server. Flight tickets booking API will run in separate server. These all are the backend APIs. These are called as backend microservices. In the backend, 3 microservices available. Like this, you can develop 20 microservices. You can develop 30, 40, 50, 100. According to your project requirement, you can develop any number of microservices. Microservice nothing but a small service which is independent service. Independently, you can develop, you can test, you can deploy, you can deliver that API to the client. A API, nothing but a REST API. One REST API is called one microservice. One microservice will contain one functionality, a specific functionality. So instead of combining hotels booking, flights booking, trains booking in a single project, we are developing 3 functionalities as 3 microservices. Microservices, nothing but pure backend APIs, no UI. UI part will be available as a separate project. When end user communicate with the UI application will communicate with the backend microservices. Every microservice will run in a separate server, and these microservices are independent microservices. Backend microservices, nothing but REST APIs. So earlier, people used to develop the project by using monolithic architecture. Nowadays, people are developing the project by using microservices architecture. Diagrammatically, are you able to understand? Diagrammatically, are you able to understand the difference between? Are you able to understand the difference between microservices architecture and monolithic architecture, guys? Diagrammatically, are you able to understand the difference between microservices architecture and monolithic architecture? Come on, guys. Are you able to understand the difference between microservices architecture and monolithic architecture? Microservices architecture and monolithic architecture. Come on. Could you please respond quickly? Could you please respond quickly? Could you please respond quickly? Are you able to understand what is the difference between monolithic architecture and microservices architecture? Come on, guys. Yes. Now, can you tell me what are the advantages available? What are the advantages available when we are going for microservices architecture? What are the advantages available for the microservices architecture? When you develop a project by using microservices architecture, what are the benefits available? Come on. What are the advantages available with microservice architecture? Come on, guys, respond quickly. I'm not getting any response. What is the advantage with the microservices? The first one is loosely coupled. Every API will be developed as separate API. Okay, microservices is an architectural design pattern. The advantage of using these microservices, instead of combining all the functionalities in one single project, we are developing the functionalities as separate APIs. Every API is a separate microservice. Okay, so hotels booking is developed as one project, flights booking developed as one project, trains booking developed as one project. So what is the benefit? The microservices are loosely coupled. The microservices are loosely coupled. What is the meaning of loosely coupling, guys? Can you tell me what is the meaning of loosely coupling? Can you guys tell me what is the meaning of loosely coupling? Can you tell me what is the meaning of loosely coupling? Come on, first. What is the meaning of loosely coupling? What is the meaning of loosely coupling, guys? Independent. One microservice is independent on the another microservice. Hotels booking we developed a separate project. We can test separately, we can deploy separately, we can execute separately. Similarly, flights booking we can develop separately, we can test separately, we can deploy separately. So the microservices are loosely coupled. That means when you make the changes to one API, there is no effect on the another API. When you make the changes to one API, there is no effect on the another API, and every microservice will run in the separate server. So burden also reduced on the servers. Burden also reduced on the servers. Earlier, everything is executed in the single server. All the requests will come to single server. So burden is increased on the server. Now, flights booking is running in one server. Flights API running in one server. Hotels API running in one server. Trains API running in one server. So every API is independent. Every API running in a separate server. So the burden is also reduced on the server. And the third advantage is easy maintenance, guys. The third advantage is easy maintenance. That means when there is a small problem, in the flight tickets booking API, I need to look into only the flights API. I don't need to touch it. I don't need to change the remaining APIs available in the project. There is a problem in the flights booking. So I will look into only this API. I will make the code changes to only the flights booking API, but not for other APIs. Maintenance of the project will become very easy. The maintenance of the project will become very easy because these APIs are loosely coupled. Because these APIs are loosely coupled, so we can make the changes to particular API. We can test only that particular API, and we can deploy only that particular API. When there is a small problem, in one API, you can debug only that API. You can modify the code of only that API. You can redeploy only that API. When there is a problem in the flights booking, there is no effect on the hotels booking. There is no effect on the trains booking. Problem is there only with the flights booking API. Flights booking API is a separate project. It is running in the separate server. There is no problem for hotels booking. There is no problem for the trains booking. You no need to modify them. The maintenance of the project will become easy, and every API running in a separate server. Burden is also reduced on the server. Burden is also reduced on the server when you are going for microservices development. When you go for microservices development, the burden is also reduced on the server. Burden is also reduced on the server. First thing, they are loosely coupled. And they are running in the separate server. Burden is reduced on the server. Maintenance of the project will become very easy. Maintenance of the project is going to become very easy. Independently we can deploy, and independently we can execute our services. Independently we can deploy, independently we can execute our services when you go for microservices architecture. When you go for microservices architecture, independently we can execute and independently we can deploy. And another biggest advantage here, no single point of failure. That means if one API is down, there is some problem for one API. If one API is down, the remaining APIs still will be up and running. If one API is having a problem, there is the hotels booking is not working, but still customers can access flights booking, customers can access a trains booking. For example, in our application, hotels booking is not working. There is some issue, some memory issue or some DB issue, some problem is available, that API is not working. So if the hotels booking is not working, but still customers can use flights booking, customers can use the trains booking. So only one API having a problem, the remaining APIs are up and running. But when you go for monolithic, if there is a problem, entire project will be down. That is a single point of a failure. So when you go for monolithic architecture, there is another challenge available. That is single point of failure. Single point of failure is available in the monolithic architecture. What is the meaning of single point of failure? If there is a small problem in the application, then the entire application is going to be down. If there is a small problem in the application, then the entire application is going to be down. We need to fix the problem and we need to redeploy the entire application. But when it comes to the microservices architecture, there is no single point of a failure. If a hotel's booking is not working, only that API is down. Still, flights booking, trains booking is working. And every functionality developed as a separate microservice, it is deployed in the separate server. Microservices nothing but loosely coupling. Microservices nothing but easy maintenance. Microservices nothing but independently deployable. Microservices nothing but no single point of failure. So what all the problems available in the monolithic architecture, to overcome those problems, people are migrated to microservices development. This microservices is one architectural design pattern. Microservices will tell you how to develop your application with loosely coupling. So application nothing but several functionalities will be available. Instead of developing all the functionalities in one project, you divide them into small services. Hotels booking, develop as one project, microservice, REST API, deploy that into one server. Flights booking, develop as one microservice, develop that as a simple REST API, deploy into one server. Flights booking, develop as one API, deploy into one server. Okay, every functionality we are going to develop as a separate API that we are going to deploy into separate server, so that my microservices, that means my application functionalities are loosely coupled. Every microservice is a separate project. Earlier, we are going to develop a single application. Now we are going to develop 3 applications. Same requirement is same. Earlier, everything in one project. Now they are divided into multiple projects. So if you keep everything in one project, there is a problem. Tightly coupling, maintenance, redeployment, single technology, burden on the server, single point of failure. To overcome all these problems, we are going for microservices architecture. It is not a technology, it is not a framework, it is not API. Then what is this microservice? It is architectural design pattern, and any project can use this design pattern in order to develop the application. Anybody, Java people can use, Python people can use, .NET people also can use this design pattern in order to develop the application. Java people can use, Python people can use, .NET people can use, anybody can use this design pattern to develop the application. So how the projects will be developed with microservices architecture? Independently deployable. So if you go for monolithic architecture, your presentation layer, your business layer, your data access layer, everything available at one place. And if you want to make a small change, there is an impact on the other functionality and you need to redeploy entire application. If there is a small problem, the whole project will be down and everything running in one server, burden will be increased on the server. That is the reason people are going for microservices. So when we go for the microservices, what is the advantage? So this is one microservice which will contain only hotels booking, that will run in one server. And this is one microservice which is for train tickets booking. It will run in separate server. This is one microservice which is for flights booking. It will run in separate server. So every functionality we developed as a separate project and it will run in the separate server. Independently deployable, independently deliverable, independently testable, independently executable. So this is advantage. Tomorrow there is a problem in this particular microservice, guys. So if there is a problem in that particular microservice, do I need to modify the other functionalities also, or I need to bother about only this particular microservice? If there is a problem with one microservice, I need to look into only this microservice. Where is the problem? I want to look into only this microservice which is having a problem. Suppose hotels booking is not working. Hotels booking is not working. If hotels booking is not working, I will check into only the hotels ticket booking. Okay, what is the problem in the hotels booking? I will check only that problem. Okay, this service is not working, so I will fix the problem only for that service. I don't need to bother about the other services which are available here. So this microservice is having an issue. When this microservice is having an issue, then I need to look into only this microservice. I don't need to touch the remaining microservice which are available in the project. I don't need to touch the remaining microservices which are available in the project. Only this is having a problem. Only one functionality is down. The remaining services are still up and running. There is no issue with them. And when I modify some code in the particular microservice, I need to redeploy only that microservice. I don't need to redeploy other microservices. Loosely coupled. Maintenance is easy. Less burden on the server because this microservice deployed in one server, this microservice deployed in one server, this microservice deployed in one server. Every microservice is deployed in the separate server. Every microservice is deployed in the separate server. So you no need to bother about burden on the server. You don't need to bother about the burden on the server. And another biggest advantage, guys, there is no need of using single database for your application. For flights booking, I'm using one database. For trains booking, I'm using one database. For hotels booking, I'm using separate database. This concept is called DB per service. In the industry, people will call it as DB per service. That means every microservice can maintain its own database. Every microservice can maintain its own database. That is called DB per service concept. Are you guys clear with my point? So if you want to use single database for all microservices, that is fine. If you want to maintain separate database for every microservice, that is also fine. It's completely depends on your requirement. Do you want to go with a single DB for all the services, or you want to use separate microservice, separate database for all your services? It totally depends on your project requirement, how you want to deal with that. So do you want to use a single microservice, or do you want to use a single database for all the microservices, or you want to use multiple databases for multiple microservices? It's up to you. DB per service concept we are going to implement. That is one advantage. And another advantage, these microservices are technology independent, guys. These microservices are technology independent. What is the meaning of technology independent here? Can you tell me what is the meaning of technology independent? Can you tell me what is the meaning of technology independent? Come on. What is the meaning of technology independent? Is there any rule that I need to develop all microservices with only one technology? Is there any rule that I need to develop all microservices with one technology, guys? Is there any rule like that? No, there is no rule like that. Okay, so this microservice I will develop by using Java. Okay, this microservice I will develop by using Python. This microservice I will develop by using .NET. This microservice I will develop by using Node.js. I can develop by using Node.js because every microservice is a separate project. They can run in the separate server. Microservice nothing but REST API. I can develop REST API by using Java. I can develop REST API by using Python. I can develop REST API by using .NET. I can develop REST API by using Node.js, REST API by using PHP. So there are so many technologies available in the market. which will support for REST API development. So one microservice I can develop by using Java, another microservice I can develop by using Python, another microservice I will develop by using .NET, another microservice I will develop by using Node.js. And every microservice is a separate project, they will run in the separate server. But when you go for monolithic architecture, if you use Java, everything you need to develop with Java only. If you choose Python, everything you need to develop with the Python only. So in the monolith, the application is technology dependent. When it comes to the microservices, so technology independent. So I want to develop 100 microservices. I don't have those many people to develop 100 microservices by using one technology. In my company, I want to start my project with Java, but only 10 Java developers available. With the 10 Java developers to develop 100 microservices will take a lot of time for me. Then what I will do? So with these 10 Java developers, I will develop a few microservices. I have Python developers in the company. Few microservices I will develop by using Python. Few microservices I will develop by using .NET. Few microservices I can develop by using Node.js. So microservice nothing but an independent project, independent REST API. In Java, you can develop REST APIs. Using Python, you can develop REST API. You can use .NET to develop REST API. PHP you can use to develop REST API. Node.js you can use to develop the REST API. I want to develop 100 REST APIs. No need to use the same technology to develop 100 REST APIs. Depends on your resources availability, depends on the people availability in the company. You can use multiple technologies to develop your REST APIs required for the project. So now if you take Make My Trip application is available. So if you see Make My Trip application is available here, do you think that Make My Trip is a monolithic application? Flights booking, hotels booking, cabs booking, trains booking, bus ticket booking, travel insurance, okay, holiday packages, homestays, villas. There are a lot of functionalities available, payments available, admin panel will be available. Okay, do you think that they develop this application as monolithic? Do you think that they will use monolithic architecture to develop this application? 100% no. 100% no. 100% no. Why? Technology dependent, burden on the server, redeployment issues, single point of failure. So there are so many drawbacks available with the monolithic architecture. That's why industry migrated to microservices architecture. Whether you are a fresher, whether you are a experienced developer, you need to work with microservices development in the company. Sir, I'm a fresher. Do I need to learn the microservices? Sir, I am having 1 year experience. Do I need to learn the microservices? Sir, I am having 5 years experience. Do I need to learn the microservices? Whether you are a fresher, whether you are 1 year or 3 years or 10 years or 15 years, you have to develop the project with the microservices architecture only in the real time. So nowadays, every company is following microservices architecture only to develop the application. So what is the microservice architecture? What is the meaning of a microservice? Microservice nothing but it is a design pattern which is used to develop our application as a small units, as a small services. Whatever the functionalities are available, instead of developing all the functionalities in one single application, we are going to develop the functionalities as small services, guys. We are going to develop them as small services here. Okay, if you develop them as small services, lot of advantages available. So what are the advantages available if you develop them as small services? Loosely coupling is available, easy maintenance is available, and you no need to redeploy all the functionality. You no need to redeploy all the services. You no need to redeploy all the services. So which service you modify, you need to redeploy only that particular service. You no need to redeploy all the services which are available in the application. Okay, and every API will run in a separate server, so there is no burden on the server. If one service is failed, if one microservice is failed, no problem, still other microservices are going to execute. And another biggest advantage is they are technology independent. There is no rule. All microservices we need to develop by using one technology. Few microservices with Java, few microservices with .NET, few microservices with the Python also you can develop. And another advantage is quick deliveries. Quick deliverables. Quick deliveries. So that means we can deliver the application quickly. That means I will develop a flights booking, I will deliver that. I no need to wait to develop all the microservices to deliver the project. Whichever the microservice you complete, you can deliver that, you can develop, you can test, you can deliver one microservice. Then go for next microservice, develop, test, deploy, deliver. So you can deliver microservices to the clients quickly. But when you go for monolith, you need to develop everything, then only you can deliver application to the client. But when it comes to the microservices, quickly you can develop one microservice and you can deliver that microservice to the client. Okay, in the real time, how the microservices will be developed. Okay, so independently deployable services, small services we are going to develop in the microservices architecture. So I hope you got the clarity. What is monolithic architecture? What are the problems available with the monolithic architecture? Okay, monolithic architecture nothing but it is a design pattern where we will combine all the functionalities in one single application. Problems available. To overcome those problems, we are going for microservices architecture. Instead of developing everything at one place, we are going to divide them into small APIs. Backend microservices will be available. Front-end UI application will be available. So whenever the request comes from the UI, then it will talk to our backend microservice. The backend microservices, multiple microservices will be available. Some microservices can communicate with one database. Some microservices will communicate with a separate database. All microservices can use the same database. All microservices can use different database. It depends on the requirement. So what are the advantages of using these microservices? Microservices are loosely coupled and they will be deployed in a separate server. So burden will be reduced on the server and the project maintenance is going to be easy and there is no single point of failure, and the microservices are technology independent and microservices are quickly deliverable. And there are some challenges also with the microservices, guys. Not only advantages, there are some challenges also available with the microservices. What are those challenges with the microservices? Can anybody tell me the challenges of microservices? We have seen advantages. What about disadvantages? What are the challenges with the microservices, guys? Any idea? Come on. Any idea on challenges with microservices? People are not responding. I want you to type in the chat box. I want you to respond in the chat box. Come on. Very few people are responding, guys. Very few people are responding. So there are some challenges available with the microservices also. What are those challenges? The first challenge with the microservice, that is bounded context. And the second challenge with the microservices, that is repeated configurations. The third challenge with the microservice, that is visibility. Okay, so these are the three challenges are available when you go for microservices architecture. Advantages are available and there are some challenges also available when you go for microservices architecture. Sir, what is the meaning of bounded context? Bounded context is nothing but deciding how many microservices we need to develop. Client has given 100 requirements. So for these 100 requirements, how many microservices we need to develop? In one microservice, what functionalities we need to implement? Deciding that boundary is a challenging task. Client has given 100 requirements. For 100 requirements, you cannot develop 100 microservices, right? For 100 requirements, do I need to develop 100 microservices? Do I need to develop 50 microservices? So in 50 microservices, so which functionality I need to develop in which microservice? Deciding the number of microservices required for our application is a challenging task. Are you guys getting my point? Deciding the number of microservices we need to develop for our application is a challenging task. So that problem is called as bounded context. That problem is called as bounded context. And the next one, repeated configurations. Next one is the repeated configurations. Sir, what is the meaning of repeated configurations here? What is the meaning of repeated configuration? So in this project, I need to configure database plus I need to configure security. Okay, so database security plus Kafka I want to use in one microservice. For database communication, some configuration I need to do for this microservice. Okay, for security, some configuration. For Kafka, some configuration. So same, my second microservice also want to use database, want to use security, want to use Kafka. Here also, I want to use database, security plus Kafka. So the configurations are going to be repeated. So a lot of duplicate configurations we need to do when we go for microservices development. So the first problem with the microservices or the first challenge with the microservices is bounded context. Excuse me guys. So when you are going for microservices development, right? So there are some advantages available and there are some disadvantages also available. So advantages we have already seen: loosely coupled, easy maintenance, no need to redeploy all the microservices. Which microservice you modify, only that microservice you can redeploy. So there is no single point of failure, and you can use multiple technologies to develop all the microservices, and your application can be delivered very quickly. Okay, then coming to challenges with the microservices, bounded context. How many microservices we need to develop? Client has given 100 requirements. For these 100 requirements, how many microservices we need to develop? 50, 60, 70, 100, 150? The number, deciding that number is difficult. So that is called bounded context. And the second problem, repeated configurations, guys. So repeated configurations, nothing but in the hotels API, I want to do the DB configuration, security configuration, Kafka configuration. Same thing for the flights booking, same thing for the trains booking. So multiple APIs should have same configurations. So repeated configurations will be available. And the next problem with the microservices is visibility. So when you are working in the microservices project, you will not get the chance to work with all the microservices in the project. You will be working with only few microservices in the project. You will understand the functionality of only those microservices. You don't know the remaining microservices functionality. You will not get the complete clarity on the project. You will not get the complete picture of the project. So they will assign only one microservice for flights booking. Okay, you work on that. How the train tickets are booking, you will not get the chance to look into that functionality. How the hotels booking, you don't know, because you are part of only one microservice development or few microservices development. Visibility problem, you may not get the chance to work with all the microservices in the project, so you will not get the complete clarity on the project. So I will tell you my scenario. So in my project, I'm working for one banking company. Okay, so from last 3 years, I'm working in the banking company, that is US based bank. So I'm working for credit card management system, credit service layer or credit card management system we are developing. So I am part of the project which is dealing with the credit cards for the US citizens. So my bank is there in US. So the customers, the citizens will apply for a credit card. They will use the credit card. So citizen credit cards available, retailer credit cards available. That means for business also we will give the credit card. That is called retail credit card. So normal citizen credit cards available, company related, business related, retail credit cards also available. So we will check the citizen eligibility. We will check the business eligibility to get the credit card payments, reminders, interest calculations. All these functionalities are part of our project. Complete credit card system management. In this credit card system management, from the last 3 years, we have developed 150 plus microservices. 150 plus. My earlier actually that project was there in mainframes. Earlier, from long back, from so many years, that bank is available. For that bank, credit card is available, project is available, but that project was available in the IBM mainframes technology. Now we are migrated that project into microservices architecture. In the last 3 years, we have migrated that credit card management system to the microservices architecture. That was a legacy project on the mainframes. I was part of that project. I was technical lead of that project. I was involved in migrating that mainframes application to microservices. 150 plus microservices we developed. I was the technical lead for that project. But I don't know all these 150 microservices because I did not get the chance to work with 150 microservices in the project. I am part of the credit card management system, but 150 microservices I don't know. So in the last 3 years, hardly 50 to 60 microservices I have touched. Some microservices scratch development, some microservices bug fixing, some microservices code review. I involved in the several phases in the development. Few microservices I developed. I know in and out what is the logic of those microservices. For a few microservices, I have done the bug fixing. I got the idea. So what the code they have done, where is the problem, how to fix it. For a few microservices, my juniors developed. I have done the code review of their microservices. So in the last 3 years of time, I got the chance to touch, or I got the chance to work with 50 to 60 hardly. I don't remember the count exactly. Hardly 50 to 60 microservices only. I know what is the business logic, how they developed, what they are doing, from where the request is coming, where the response is going, what is request, what is response. So I know about only 50 microservices in my project. I don't have complete picture of my project. I don't know how the complete system will work because 150 microservices are there. But I was part of 50 to 60 microservices. 100 microservices I don't know. So that is the reality. Visibility problem. I will not get the time. I will not get the chance to work with all the microservices available in one. I'm part of the project. I'm technical lead earlier, now promoted to manager, but still I don't have the clarity on the 150 microservices in the project because I was lead for few microservices. I am the manager for few microservices. I was developer for few microservices. I was the code review member for few microservices, but not for all. That is the visibility problem in the microservices. I'm working on the project from 3 years, but still there is no clarity. Still there is no complete picture of my project microservices. So that is the visibility problem. If it is a monolithic application, everything will be available at one place. Complete code you can download from the GitHub. You can run that code in your system. You can debug. You can understand everything. But microservices not like that. Every microservice, separate Git repository, separate permissions will be available. You cannot download all the microservices from the GitHub. They will give the permissions for only the microservice which you are working on. My DevOps team will manage that. Role-based access will be available. I can't download the source code of 150 microservices. I don't have a permission for that because it is a banking company, lot of security. So lot of rules and regulations, lot of policies will be available. So when you are working with the microservices architecture, this visibility problem will be there. Do you agree with me? Anybody facing the same problem? Anybody face the same problem? Rakesh Kumar is saying that this is not microservices class. Then what is this class, sir? Mr. Rakesh, this is not microservices class, huh? Then what is this class? Somebody is commenting that, sir, this is not microservices class. When microservices will start? So he's feeling that it is not microservices class. Yeah, there are so many people are facing the same problem, that is called visibility problem. So many people are facing the same problem in the industry, that is called visibility problem. So visibility problem means you will not get the chance to work with all the microservices available in the project. So you will get the chance to work with only few microservices in the application, not with all the microservices. So I hope you got the clarity on what are the challenges available with the microservices. One is bounded context, next one is repeated configurations, and the third one is visibility problem. One is bounded context, next one is repeated configurations, third one is visibility. So with this, theoretically we understood what is monolithic architecture and what is microservices architecture, what are the drawbacks with the monolithic architecture, and what are the advantages with the microservices architecture. Are you guys clear? So in the industry, application can be developed in two ways. One is by using monolithic, another one is by using microservices. What is the meaning of a monolithic? What is the meaning of a monolithic, guys? Developing all the functionalities in the single application is called as monolithic architecture. There are some problems available. Project is going to be tightly coupled. The project maintenance is going to be difficult. So if you make a minor change in the project, you need to redeploy entire application, and the project should be developed by using one technology. Your project is going to be technology dependent, and it will increase burden on the server. There is a chance of server crash also, and there is a problem, single point of failure. If there is a small problem, entire application is going to be down, then that is called single point of failure. To overcome the problems of monolithic architecture, people are using microservices architecture. Then what about the microservice? Microservice is not a technology, or it is not a language. It is not a framework. It is not API. Then what is microservice? Microservice is an architectural design pattern. So it is universal design pattern. It is universal design pattern, guys. Anyone can use, any language specific developer, any technology specific developer can use this architecture to develop the application. What are the advantages available with the microservices? Microservices are loosely coupled, and burden will be reduced on the server. Burden will be reduced on the server. Easy maintenance, project maintenance is going to be easy. Okay, so if one service is having a problem, you no need to worry about that. Other services still work. So there is no single point of failure. You no need to redeploy all the microservices. If you make a code changes for a hotels booking project, only you need to redeploy hotels booking service. Hotels booking is developed as one REST API. Flights booking is developed as one REST API. Trains booking is developed as one REST API. These all are the backend REST APIs. They will run in the separate servers, and multiple microservices can communicate with the single database, or every microservice can maintain its own database. Microservices will contain only business logic, backend functionality. For all these microservices, front end will be developed as a separate application. UI application will be separate. Our backend APIs will be separate. Backend APIs are microservices. So these microservices are easy to maintain. They will run in the separate server. They are loosely coupled, and they are technology independent, and very quickly we can develop and we can deliver microservices to the clients. Okay, and what are the challenges available with the microservices, guys? What are the challenges available? When we are developing the microservices, some challenges we have to face. What are those challenges? First one, bounded context. What is the meaning of bounded context, guys? Bounded context is nothing but identifying how many microservices we need to develop for one application, and deciding which functionality we need to add in which microservice. So client has given 100 requirements. For these 100 requirements, how many microservices we need to develop? For these 100 requirements, how many microservices we need to develop? deciding that factor is very difficult. Deciding how many microservices we need to develop in one application, that is very difficult, guys. That is very difficult. Deciding how many microservices we need to develop and which functionality we need to add in which microservice, that is difficult. Okay, so that problem is called bounded context. Bounded context means identifying how many microservices we need to develop for one application and deciding which functionality we need to add in which microservice. And the next one, in several microservices, we need to write some configurations like data source configuration, SMTP configuration, Kafka configuration, Redis configuration, etc. So there are 30 microservices available in my application. So in 30 microservices, data source configuration, Kafka configuration, Redis configuration, security configuration we need to do. So that is called repeated configurations will be available. That is called repeated configurations will be available when we go for microservices architecture. And the next one, in the microservices architecture, we might not get the chance to work with all APIs available in the application. So I told you my scenario. 150 microservices available in my project, but I know only 50 microservices functionality. The remaining microservices I don't know. I don't have the complete picture of my project. So that is called visibility problem. What is that problem is called, guys? That problem is called as visibility problem in the microservices architecture. So do you agree with me? These are the challenges we need to face as a microservices developer. Will you agree with me? These all are the challenges we need to face as a microservices developer. Yes, as a microservices developer, we need to face all these challenges. We need to face all these challenges. Okay, good. Guys, one small announcement for you. Okay, so Monday session, tomorrow also we have a class. In the Monday session, I'm going to start one new batch for DevOps with AWS Cloud. So I'm going to start one new batch for DevOps with AWS Cloud. We are going to cover Linux, shell scripting, AWS Cloud, DevOps tools, 15 plus DevOps tools like Maven, Git, Jenkins, Docker, Kubernetes, Terraform, Ansible, and Grafana, Prometheus, Trivi, like that. 15 plus DevOps tools we are going to cover. 15 plus AWS services I'm going to cover. Linux and shell scripting also I'm going to cover as part of this DevOps with AWS. So this is starting from Monday at 8 p.m. IST. So daily live classes will be available. Soft copy notes you are going to get. Backup videos also will be available. So if anyone is interested to learn DevOps with AWS Cloud from me, then you can join for the demo session. You can attend the free demo session on Monday. The Zoom registration link also I have sent in the Zoom chat. If anybody is interested, then you can join. This course fees is going to be 16,000 rupees, including live classes plus backup videos. Soft copy material, live classes and backup videos will be available. Definitely it is going to be a wonderful session. So if you are from any background, whether you are from IT background or non-IT background, you are from Java, you are from Python, you are from .NET, happily you can learn the DevOps with AWS, because nowadays every developer also should have the knowledge on cloud computing. Every developer should know operations in the project, how to write a Docker file, how to deploy application in the Kubernetes, how to create a Jenkins CI/CD pipeline, how to create infrastructures in the AWS cloud platform. Everything we are going to discuss practically. The course is going to take 3.5 months, 3 to 4 months of time it is going to take. Every day is a live session and every class is practical. So my experience I'm going to share in this DevOps with AWS cloud. So Linux we are going to learn, shell scripting we are going to learn, AWS cloud we are going to learn, and DevOps tools we are going to learn, like Docker, Kubernetes, Jenkins and all. Okay, the fees is 16,000 rupees. Yeah. So I have given the information in the chat box. If you are interested to attend the free demo session, Monday sharp at 8 p.m., 8 to 9:30, daily 1.5 hour session will be available. Monday, 8 p.m. to 9:30 p.m., the demo session will be available. So what we are going to cover in that course, so everything I'm going to explain in the demo session. So you can take the screenshot of this. Zoom link also available here. You can take the screenshot of this. or else I have given in the chat box also, you can register. Okay, good. And if you have any of your friends who are from non-IT want to come into IT, then this course is best suitable for them. So you can inform them to attend the demo session on the Monday. Good. Fine. Perfect. So what are the challenges with the microservices that we understood? Bounded context is one problem. Bounded context is one problem. That means deciding the number of microservices, how many microservices we need to develop, deciding that number is the biggest challenge. Okay. And when we are working with multiple microservices, repeated configurations we need to do. So in one microservice, we are going to communicate with the database, security, Kafka, Redis configurations. In another microservice also, I want to do the same thing. So I need to repeat the configurations here. Duplicate configurations we are going to write in the microservices, and visibility problem will be available. So you may not get the chance to work with all the microservices which are available in the application. Are you guys clear with my point? So they are asking, sir, as a Java developer, do I need to learn the DevOps? Nowadays, every developer, whether you are a Java developer or Python developer, every developer should know cloud computing. Every developer should know operations. DevOps is for everybody now. So when you go for the interview, definitely they will ask you questions. How do you use Jenkins? How do you write Dockerfile? How do you deploy your application? How to create CI/CD pipeline? Can you tell me how do you deploy your application in the AWS cloud? Can you tell me how you will connect your Spring Boot application with the cloud database? Can you tell me how do you use storage in the cloud? So these are common. Nowadays, the cloud computing, the DevOps tools are common for every developer. So that course is definitely going to help you. If you're already working professional also, that course is going to helpful. You can attend 2 to 3 demo classes for free of cost. Then you will understand whether that course is suitable for you or not. Okay. So demos are free of cost. You can attend 2 to 3 days free demo sessions. If you are liking that, then you can continue. The Zoom registration link for the DevOps demo I have given in the chat box. Nowadays, many companies are asking developers to perform the DevOps operations also. Nowadays, many companies are asking the developers to perform the DevOps operations also. So Vaidehi, sharing your experience. Vaidehi, can you tell me what is your experience in the company? Are they asking you to perform operations also in the project? So what is your current role in the company? You are a developer or operational engineer?
No, I am right now a developer, senior developer, but sometimes for the development environment, because there are so many environments in projects, development, UAT, then staging, and then production. So mainly DevOps people take care of production, but development and staging can be done by the developers. The company shares that responsibility with the developers.
Yeah, so nowadays many companies are asking developers to perform the deployments also. So if you are a developer and if you want to perform the deployments also, you should know Linux, you should know cloud, you should know DevOps tools. So it's very important for you to survive in the job. So if you are interested, you can attend the demo on Monday at 8 p.m. Zoom link I have given in the chat box. So if you want to register for the demo, I will wait for 1 minute. You can complete your registration. Then I will start the session. Anybody registering for the demo session? How many of you interested to attend the demo of DevOps? Registered. Okay, good. Yeah, if you're interested, you can register. I will wait for 1 minute. Now I am going to explain the real microservices architecture. Theoretically, we understood these points. Now we need to understand these points which are very important of this session. The real microservices architecture we are going to learn now. So before going to do that, if you are interested for registering for the demo, you can register. Then I will get started with the real microservices architecture. We understood theoretically what is monolithic, what is microservices, advantages with microservices, drawbacks with the microservices. Now let us start with the real microservices architecture. Let us start with the real microservices architecture. Shall we start or you need a break? Shall I explain the microservices architecture, or you want to take a 5 minutes break? Anything is fine for me. You need a break, huh? Okay, then it is 9:55 now. We will start at 10:05, guys. Don't miss the next session. Next 1 hour, we are going to understand these concepts. What are these things? What is a service registry? What is admin server, Zipkin server, API development, inter-service communication, API gateway, config server? What is the purpose of these concepts? What is the architecture diagram? How the microservices architecture will be available? So we'll discuss in the next 1 hour of time. Okay, so let us take 5 minutes of break, then we will get started. Don't disconnect from the Zoom. I will just pass the recording. Okay, you can come back after 5 minutes of time. Session will start in 5 minutes. We are going to talk about microservices architecture. So what is service registry, what is API gateway, and all we will start. So take break for 5 minutes. Good, guys. So you can come back, you can have some water and you can come back. Session will start at 10:05. Yeah, 5 minutes break. Good. Good morning, guys. So welcome back. Now we are going to understand the real microservices architecture. Now we are going to understand the real microservices architecture. Theoretical part is completed. Let's understand the real microservices architecture. Vaidehi want to share something? Yeah. Hi Vaidehi, you can unmute your mic and you can speak out.
Yeah, hi, hello, how are you all? Actually, this incident happened just a month ago. My company wanted to shift on ELK stacks, and they were installing those, and they were having some issues, and they were just discussed with me. I asked them to refer your video, and they come out of that problem because in your video, in only your video, that configuration was mentioned. So this security configuration need to be changed, and that really that incident proven that your videos are very informational, and actually they are based on real experiences. We have go through your videos when we encounter some problem. Let's have some reference from your videos.
Thank you so much. Good.
Thank you, sir. You took so many efforts for these videos and these workshops.
Yeah.
Thank you. Thank you.
Welcome. All right. Abhi, you want to share something? Okay. Yeah, Abhi, you can unmute your mic. Hi,
Yes, sir.
Mr.
Yeah, hello, sir.
Yeah, hi, Abhi.
Yes, sir. No, sir. In my company, as Vaidhi shared, like we are implementing Kafka, and my lead and my other colleagues has no idea. Like we need to implement it in a quick time frame. So I recommended there your video Kafka video.
Oh, okay.
They have after that they have implemented.
Okay, sir. Good. Thank you. So you referred our Kafka video in the YouTube channel to implement in your project. Good. Thank you. Thank you so much, guys. So this kind of your experience, right, is giving more energy for me. So it will give more energy to do more kind of workshops like this. Thank you so much. All right, let's get started with our microservices architecture, guys. The very first important thing that we need to understand, there is no fixed architecture for microservices, guys. There is no fixed architecture for microservices. People can customize microservices architecture according to their project requirement. We can customize microservices architecture according to our project requirement, guys. There is no standard. That means you need to use API gateway. You need to use a service registry. You need to use separate database for every microservice. Like that, there is no rule. There is no specific rules available in order to follow microservices architecture, guys. So that is the reason I'm trying to say here, there is no fixed architecture for microservices development. So whatever is suitable for your project, whatever is your project requirement, based on that we can customize microservice architecture according to our project requirement. So when we are implementing microservices architecture, as part of microservices architecture, we are going to use below components, guys. And all these components are not mandatory. All the below components are not mandatory. Whatever is required for your project, you can use that component and you can implement that component in your project. So in the industry, there is no fixed architecture for microservices development. We can customize microservices architecture according to our project requirement. As part of microservices architecture, we are going to use below components. All the below components are not mandatory. Sir, what are those components? The first one is service registry. In every microservices development, we are going to use service registry, which is called Eureka server. We are going to use Eureka server as a service registry, and we are going to use admin server in our microservices, and we are going to use Zipkin server in the microservices. Okay, and we are going to use config server in the microservices, and we are going to use Kafka server in the microservices, and we are going to use Redis server in the microservices, and we are going to use Feign client in the microservices, and we are going to use API gateway in the microservices. We are going to use API gateway in the microservices. So when we are going for microservices development, there is no fixed architecture for the microservices development. We can customize this architecture according to our project requirement. As part of this architecture, we are going to use below components. All the below components are not mandatory. Whatever the component is required for your project, you can use that. So what components generally we are going to use in the microservices architecture? Service registry will be available, admin server will be available, Zipkin server will be available, config server will be available, Kafka server will be available, Redis server will be available, Feign client will be available, API gateway also will be available. Let me show you diagrammatically the microservices architecture. So first one, for every project, when we are going to develop the microservices, first thing that we are going to take, that is service registry. I will tell you what is this service registry, what is the role of the service registry in the microservices architecture. First, let's understand the architecture diagram. Service registry is available, and the next one we are going to use admin server. Next one we are going to use admin server. Just understand the diagram, understand the component architecture now, then we will discuss about what is the purpose of them. Admin server will be available and Zipkin server will be available. Admin server, Zipkin server will be available, and similar to this, config server will be available. Similar to this, config server will be available, and in some projects we are going to use Kafka server. Kafka will be available. Kafka will be available. In some projects, Redis will be available. Kafka server will be available and Redis server will be available, and we are going to use ELK stack also. ELK stack, ELK servers will be available. Okay, so service registry will be available in the microservices. Admin server will be available. Zipkin server will be available. Config server will be available. Kafka will be available. Redis will be available. ELK also will be available. Now, after these things, then actual microservices will be available here. Microservices nothing but our backend APIs. Multiple APIs you can take. API 1, API 2, API 3. According to our requirement, we can take multiple backend APIs in the application. This is my API 1, this is API 2, and this is API 3. So like this, you can take multiple APIs according to our requirement. API 1, API 2, and API 3 is available. Now, what are the backend APIs are available? All these backend APIs are going to register with the service registry. And these APIs will register with the admin server. APIs will register with the Zipkin server. API will register with the config server. APIs will register with the Kafka. APIs will register with the Redis server. APIs will register with the ELK also. And one API can communicate with the another API, that is called inter-service communication. One API can connect with the another API, that is called inter-service communication. Okay, next one, in order to manage all these APIs, we are going to have one more API which is called API gateway. We are going to have one more API which is called API gateway in our application. Okay, that API gateway also going to register with the service registry available in the project. API gateway will register with the service registry. Then, so this is our complete backend application microservices development. Instead of ELK, you can say that it is a database, or database also will be available. And this is microservices architecture. Okay, in the real time, when we are developing our application with the microservices, generally, this is the architecture we are going to follow. But as I told you, this is not fixed, guys. In some projects, they may not use Kafka. There is no scenario. If they don't need Kafka, they will not use it. If they don't need Redis server, they may not use it. Database, definitely every microservice will have database communication. Some people don't use a config server. Some people don't use a Zipkin server. Some people don't use admin server. Some people don't use inter-service communication. So there is nothing mandatory here. There is nothing mandatory. So according to our project requirement, what is required, that you can use. So that is what I told you. There is no standard architecture for the microservices development. So according to your project requirement, you can develop this architecture. You can customize this architecture according to your project requirement. So what are the components that we are taking here? So service registry is available. Admin server is available. So this is service registry, and this is admin server, and this is Zipkin server, and this is config server. And we are having Kafka server, we are having Redis server, and we are having database also. Whether we are going to use one database or we are going to use multiple databases, that it depends on the project requirement. Some project may use only one database, some project may use multiple databases. And here API gateway is also available. So in the real time, when we are developing the microservices, most of the people, most of the companies, most of the project will follow this kind of architecture, and according to their requirement, they can change this also. It is not mandatory. It is not mandatory to follow this architecture. They can customize this architecture according to their requirement, guys. According to their requirement, they can customize this architecture also. Are you guys able to follow me? Are you guys able to follow me? What is the standard architecture available for the microservices? Guys, is my voice audible for everybody? Is my voice audible? Is my video also visible? Is my video also visible? Both are clear, right? Very good. Good. So we are going to understand microservices architecture. There is no fixed architecture for the microservices development. We can customize microservices architecture according to our project requirement. As part of microservices microservice architecture, we are going to use below components. All the below components are not mandatory. We can use them based on demand or based on requirement. So what are the components we are going to use? Service registry will be available, admin server will be available, Zipkin server will be available, config server will be available, Kafka server is available, Redis server is available, Feign client is available, API gateway also available. Now let's understand what is the purpose of all these components. Look at the diagram. Just observe the diagram for 1 minute of time, guys. All of you, can you observe this diagram for 1 minute of time? All of you, can you observe this diagram for 1 minute of time? Just look at the diagram. Just look at the diagram for 1 minute. What is this Feign client? What is this service registry? Everything we are going to discuss now only. What is the purpose of all these components, I will tell you, and how to implement the project with all these components. Tomorrow we are going to do the coding. Today theoretically we will understand what is the purpose of this. Tomorrow practically we are going to implement them. Today theoretically we are going to understand these components. Tomorrow practically we are going to implement them. Are you clear? Are you clear? Feign client is not missing. Here Feign client will come into picture. Inter-service communication we are going to do with the Feign client. One microservice will communicate with another microservice by using Feign client. FC. Feign client will come into picture when one microservice is going to communicate with the another microservice. Are you guys able to look at the diagram? Are you guys able to look at the diagram? Microservices architecture. Is it a fixed architecture that everybody will follow in the company, or it is optional, guys? Is it fixed architecture that everybody will follow in the company, or it is optional? Is it fixed architecture or it is optional? You can customize this architecture according to your requirement. It is not mandatory to use all these components in the project. Whatever is required for the project, that you can use, and remaining parts you can ignore. So now let's understand what is the purpose of each component available in this architecture. Let's understand each component available in this architecture. So the first component here, that is service registry. The first component here, that is service registry. So what is the meaning of service registry? Service registry is used to maintain all the services which are available in our project, guys. So API 1, API 2, API 3, admin server, Zipkin server, config server, like that there are so many microservices available. We can say service registry is one microservice, admin server is one microservice, Zipkin server one microservice, config server one microservice, API gateway one microservice, API 1, API 2, API 3, 6 plus 2, total there are 8 microservices available in this diagram. What are the 8 microservices available in this diagram? API gateway is one microservice, service registry one microservice, admin server one microservice, Zipkin server one microservice, config server one microservice. Here API 1 one microservice, API 2 one microservice, API 3 one microservice. So total there are 8 microservices are available. So how do you know how many microservices available? What is the name of the microservice? What is the URL of the microservice? What is the status of the microservice? So all the microservices of our application, all the microservices information of our application, we can maintain by using service registry. What is the purpose of this service registry? Service registry is used to maintain all the API's information like name of the API. API means microservice. So service registry is used to maintain all the API's information like name, status, URL and health at one place. So in our project there are 10 microservices available. So what all the microservices available? What is the name of each microservice? What is the status, whether they are running or stopped? What is the health? What is the URL? All the microservices information I want to monitor at one place. That's where service registry microservice comes into picture. So what is a service registry in the microservices architecture? Service registry is used to maintain all the microservices information at one place. It is a register where you can see what microservices available for our project, what is the name of each microservice, what is the status of each microservice, that means running or not running, what is the health of the microservice, what is the URL of the microservice. All the information about our microservices we can access at one place, that is service registry. This service registry is also called as service discovery. By using name of the microservice, we can identify the URL of the microservice. That's why it is called as a service discovery also. And how can we use this one? We are going to use Eureka server as a service registry. Sir, how to set up service registry for our application? To set up service registry for our application, we are going to use one server. That server is called as Eureka server. Which one we are going to use as a service registry for our application, guys? So in the Spring Cloud, when you go for, sorry guys, when you go for Spring Cloud library, let me take water. There is a change in the voice. Yeah, we are trying to, is it clear now? Is my voice clear now? Is it clear now? Yeah, good. So we are trying to understand what is service registry. You got the clarity? What is the purpose of service registry? Service registry is used to maintain list of services available in our application. So in one application, multiple microservices can be available. What microservices are available in one application, we can maintain by using service registry. This service registry is also called as discovery server or service discovery. So which one we can use as a service registry? We can use Eureka server as a service registry. Okay, Eureka server is provided by Spring Cloud libraries. Eureka server provided by Spring Cloud libraries. Okay, so if you want to use Eureka server, then we need to add Spring Cloud library in our application. How we are having Spring Core module, Spring Data JPA module, WebMVC module. Similarly, Spring Cloud module is available. By using this Spring Cloud module, we can use service registry. So what is the purpose of this service registry? Service registry is used to maintain all APIs information like name of the API, status of the API, URL of the API, health of the API. All the APIs information we can access at one place by using service registry. This service registry is also called as service discovery. How to set up the service registry? To set up the service registry, we are going to use Eureka server. Who will give you that Eureka server? Eureka server provided by Spring Cloud library. Okay, and this service registry will provide one user interface to get the APIs information. It will give you one dashboard. It will, if you create a service registry project, that service registry project will give you one dashboard. In that dashboard, you can access all the microservices information. How many microservices available? What is the name? What is the URL? What is the status? What is the health? How to access them? All the microservices information we can access in the service registry dashboard. Eureka server we are going to use as a service registry. There are some alternates also for the Eureka. In the Spring Cloud, Eureka server available, which we are going to use as a service registry, which is free of cost. What is alternate for Eureka? The alternate for the Eureka, console is available. There is another server, console server, which we can use as a service registry. And cloud, AWS service registry available. AWS service registry available. Azure service registry, like means cloud providers also will give you service registry to monitor your microservices. But cloud service registries are costly. We need to pay the money. But when you go for Eureka, which is free of cost. So that's why as part of our microservices development, we are going to use Eureka Server as a service registry, which is free of cost. It is part of Spring Cloud Library. Are you clear with my point? What is the meaning of service registry? Are you clear with my point? What is the meaning of service registry? Service registry is used to maintain all the API's information like name of the API, status of the API, URL of the API, health of the API. We will use Eureka Server as a service registry. That is part of Spring Cloud. So it will provide user interface to get the API's info. Sir, how to get that user interface? Tomorrow we are going to do the coding for this, right? So in the coding, we will build one microservice called service registry microservice. Then we will see the information of the microservices. Theoretically, are you clear? What is service registry? Theoretically, are you clear? What is service registry? Yes. Good. So Eureka is a service registry. We are going to use the alternates for the Eureka. Console is available. Cloud provided service registries, paid service registries are available in the market. Next one, in the diagram, if you see the next one, admin server. So what is the meaning of this admin server? Admin server is used to monitor and manage all the APIs at one place. That means I want to check the health of the APIs. I want to see configuration properties loaded by the APIs. I want to see what are the beans loaded by the APIs. I want to see logs of the loggers available for the API. I want to change the log level of the API. Okay. So generally in the Spring Boot, we know actuators concept. Actuators are used to monitor and manage the APIs. So for this, microservices. API 1 is having actuator. API 2 is having actuator. API 3 is having actuator. All these actuators I want to monitor by using one dashboard. At one place I want to monitor all the APIs. So to monitor all the microservices, to manage all the microservices at one place, we are going to use admin server. So already in the Spring Boot, actuators concept available. What is the purpose of the actuators? Actuators are used to monitor and manage your microservices, your Spring Boot applications. So API 1, 2, 3, like the 10 APIs available. 10 APIs are having the actuators. Accessing actuators of 10 APIs is individually difficult. I want one user interface where I can monitor all the APIs at one place. That's where admin server comes into picture. So what is this one service registry? Only to tell you what are the microservices available, what is the name, what is the status, what is the URL. By using this admin server, we can manage them. We can monitor and manage all the APIs at one place. Example, health check. We can do health checks and we can see config props. We can see the config props. We can see URL mappings. We can see URL mappings and we can see beans loaded. We can see beans loaded on changing log levels, all kind of things. All these kind of things we can perform by using admin server. So this is used to monitor and manage all your APIs. API in the sense REST API. REST API nothing but microservice. So all the microservices we can monitor and we can manage at one place by using admin server. This admin server also will provide a beautiful user interface to access API's actuator endpoints at one place. So if you know the actuator concept in the Spring Boot, the actuator concept is used to monitor and manage your APIs. So instead of accessing the actuator endpoints separately, all the API's actuators we can access at one place with the user interface. For that reason, we are going to use admin server. Admin server is used to monitor and manage all the APIs at one place. What we can monitor? We can do the health checks of the APIs. We can see the config props loaded by the APIs. We can see URL mappings of the APIs. We can see the beans loaded by the API. We can change log levels of the APIs, thread dumps of the APIs, heap dumps, thread dumps you can download, heap dumps you can download, thread dumps and heap dumps we can download by using this admin server. Admin server will provide you user interface in order to manage and monitor all the APIs at one place. Are you guys able to understand what is the purpose of service registry and admin server? Both are same or both are different? Guys, service registry and admin server both are same or both are different? Service registry to know what all the services available. Admin server to monitor and manage all the APIs at one place. Okay. And the next one, there is another server is called, which is called Zipkin server. There is another server available which is called Zipkin server. So what is the meaning of Zipkin server? What is the purpose of Zipkin? Zipkin server is used for tracing the request. It is used for distributed tracing of our requests. So that means by using this Zipkin server, we can understand how much time taking to process one request processing time. So customer send one request to our application. In our application, microservices available. How much time it is taking to process the request? Which microservice is taking? Which microservice taking more time to process? Okay. How many services involved in the request processing? How many services involved in one request processing? So when I send one request, that request executed by only one microservice, or that request executed by multiple microservices? If the request executed by multiple microservices, how much time each microservice has taken to process that request? Which microservice is fast in processing the request? Which microservice is slow in processing the request? All that information we can track by using Zipkin server. So what is a Zipkin server? Zipkin server is used for distributed tracing of our requests. So what we can get by using this Zipkin, we can understand how much time taking to process one request, which microservice is taking more time to process, how many services involved in one request processing. All that data we can get by using one server called Zipkin server. This Zipkin server also will provide one dashboard. Zipkin server will provide one beautiful user interface to access API's execution details. So customer sent one request to our application, which microservice executed to process that, how many microservices processed that request, which microservice taking more time, which microservice is taking less time. All that information we can access by using Zipkin dashboard. Zipkin server we are going to use to implement distributed tracing of our requests in the microservices architecture. Service registry, admin server, Zipkin server. Service registry to know the APIs available in the application, status, name, URL. Admin server to monitor and manage all the APIs at one place. And the next one, Zipkin server. Zipkin server is used for distributed tracing of our request. So which request came, which service executed, how much time they taken, which service is taking less time, which service is taking more time. All this information we can access by using Zipkin server. Okay, are you guys clear with the purpose of Zipkin server in the microservices architecture? Are you guys clear with the purpose of Zipkin server in the microservices architecture, guys? I'm not getting the response. I'm not getting the response. Next one. Another server that we are using in the microservices architecture, that is called config server. Another microservice component, that is config server. What is the config server? Config server is used to separate application code and config properties. Application properties. Earlier in the Spring Boot project, when we developed the Spring Boot application and properties file will be available. Database properties, Kafka properties, Redis properties, everything we will configure within the project application and properties file or application and YML file. So if you keep the database properties within the application, it is tightly coupled. So we need to separate configuration properties and source code. So that's where we are going to use config server. Config server is used to externalize config properties. It is used to make our application loosely coupled with the properties file or YML file. Earlier, when we are developing the boot application, properties file by default will be created. Data source we will configure. Data source details we will configure in the properties file. But tomorrow, if I want to connect with a different database, I need to change the properties file. I need to recompile the project. I need to repackage the project. I need to redeploy the application. Application will be tightly coupled with the properties file. If you write your properties, data source properties, SMTP properties, and the next one, Kafka properties, Redis properties, anything, if you write within the project is tightly coupled. Tomorrow, I want to connect with a different database. I want to change the database credentials. Then again, you need to repackage, you need to recompile, repackage, redeploy. To overcome that problem, we are going to use config server in the real time. So what is the purpose of config server? It is used to separate application code and application properties. Application and properties file we will load from outside of the project. Earlier, whenever we are developing a boot application, properties file and YML file is there within the project. But in the real time, we need to keep the properties file outside of the project and we need to load into our application. To make our application loosely coupled with the properties file or with the YML file, we are going to use config server concept. Very important in the real time. Nowadays, in every microservice application, config server is used, which is used to externalize configuration properties from our application. So earlier, when you create, generally, when you create a boot application, start class will be created, properties file also will be created. Properties file is there within the project. If you keep the properties file within the project, tightly coupled. We need to load it from outside. How to load the properties file from outside? By using config server. So what we can achieve by using config server? By using this config server, we can achieve loosely coupling with the properties file. Service registry, that means Eureka server, admin server, Zipkin server, config server. Are you clear with my point? Service registry, admin server, Zipkin server, config server. So what is the meaning of service registry? Service registry is used to maintain all the API's information at one place. It is also called as service discovery. We are going to use Eureka server as a service registry. It is provided by Spring Cloud. Next one, admin server. What is the purpose of admin server? Admin server is used to monitor and manage all our APIs at one place. We can do health checks, config props, URL mappings, beans loaded, thread dump, heap dump. So change the log level. In the interview, they asked this question. Currently, my project log level is info. Without restarting the project, I want to change it to debug level. How do you do that? By using admin server. So this is very famous interview question. My application running in the production, my application log level is, root log level is info. Now I want to downgrade it to the debug level without restarting the project. How can you change the log level without restarting the project? That's where admin server comes into picture. So what is the purpose of admin server? It is used to monitor and manage all the APIs at one place. So this kind of information we can access by using admin server. So this Eureka server will provide user interface, dashboard will be given to you. Admin server also will give the dashboard for you, and Zipkin server is available. That Zipkin server also will provide a dashboard for you. What we can do by using Zipkin server? Zipkin server is used for distributed tracing of our request. Okay, how many microservices involved in the request processing? Which microservice is taking how much time to process the request? And the next one, config server is available. What is the purpose of config server? Config server is used to separate application code and application properties. So generally when you are doing the practice, when you are developing the boot application, properties file will be available within the application. That's not recommended. So in the real time, properties files will be available outside of the project and we will load them by using config server. Are you guys clear with these concepts? Service registry, admin server, Zipkin server, and config server. Are you able to understand? Are you able to understand what is the purpose of service registry, purpose of admin server, purpose of Zipkin server, purpose of config server? Could you please respond in the chat box? Could you please respond in the chat box? Come on. Yes. Yes. So today, theoretically, we are understanding. Tomorrow, we are going to develop a project, guys. Whatever I am discussing today, tomorrow we will develop the code. Practically, we will see everything. So I told you, this is not just a theoretical session. Java microservices development, Java microservices with a mini project development. So tomorrow, in the tomorrow Sunday session, tomorrow morning at 8 o'clock, we are going to start, right? So in the tomorrow session, we are going to develop a project. Whatever the theory you are learning today, tomorrow we will implement that in our project. Got it? So tomorrow, once you do the coding, then you will get the clear picture. Once we do the coding, then you will get the clear picture of that. Next one. Here, our actual microservices are available. API 1, API 2, API 3. These are our REST APIs that we are going to develop. API 1, API 2, API 3. These are our microservices we are going to develop. Whatever the microservices we are developing, those are called backend APIs, which will contain the business logic. So API 1, flight tickets booking. API 2, train tickets booking. API 3, hotel ticket booking. So according to our requirement, you can develop any number of APIs in the project. So in the diagram, I have taken 3 APIs. And observe, whatever the 3 APIs I am taking, this API is acting as a client for Eureka. Our API will act as a client for Eureka. Our API will act as a client for admin server. Our APIs will act as a client for Zipkin server. Our APIs will act as a client for config server. Eureka server available, admin server available, Zipkin server available, config server available. Okay, and our APIs, our actual microservices we are going to develop. Our microservices will act as client for Eureka, will act as client for admin server, will act as client for Zipkin server, will act as client for config server. How to act as a client in the coding, we are going to do that. I will develop one microservice. My microservice will register with Eureka. You can see the arrow marks I have given. So my APIs, API 1, 2, 3, up to 100 also, no problem. All our microservices will register with Eureka, will register with admin server, will register with the Zipkin server, will register with the config server. So our APIs are going to act as a clients for Eureka, for admin, for Zipkin, for config server. Now, whatever the APIs we are developing, one API want to communicate with the another API. When one API want to communicate with the another API, we are going to use Feign client. We are going to use Feign client. What is the meaning of a Feign client? Feign client is used for inter-service communication. What is the meaning of Feign client? Feign client is used for inter-service communication. So one microservice want to communicate with the another microservice is called inter-service communication. So this inter-service communication will happen with the help of service registry. So API 1 want to access API 2, API 2 want to access API 3, then we are going to use Feign client to achieve inter-service communication. Under these microservices, I'm going to implement load balancing also. That means one microservice I'm going to deploy in multiple servers in order to achieve load balancing. For the load balancing, we are going to use ribbon concept. For my microservices, load balancing. If you see 2 boxes I have given, 2 boxes, nothing but 2 instances. My second API will run in 2 servers. Same microservice I will run in 2 different servers for load balancing. So those are called 2 instances. How do we achieve those 2 instances with load balancing? Ribbon concept we are going to implement. I will show you microservices load balancing also. I will show you microservices load balancing also by using ribbon. So if you see API 1 having 1 box, nothing but it is running in 1 server. API 2 having two boxes, nothing but it is running in two servers. Why we will run one microservice in two servers? For load balancing. How to achieve load balancing? By using ribbon. Where is that ribbon? Available in the Feign client. Okay, what is this Feign client? Feign client is used for inter-service communication. If one API is communicating with another API within the same application, then it is called inter-service communication. So I'm developing multiple microservices here. One API want to communicate with the another API, then it is called inter-service communication. How we will achieve that inter-service communication? By using Feign client concept. Are you clear? What is the meaning of a Feign client and why we need to use the Feign client? Are you clear? What is the meaning of a Feign client and how do we use the Feign client? What is the purpose of the Feign client? Feign client is also Spring Cloud library. Feign client is also Spring Cloud library that is used for inter-service communication. That is used for inter-service communication. What is the meaning of inter-service communication? Within my project, there are multiple microservices available. One microservice wants to communicate with the another microservice, that is called inter-service communication. Are you clear with my point? Next one. What is API gateway? So here API gateway is like a security guard for our microservices project. So what is the meaning of API gateway? API gateway is going to act as a front controller. API gateway act as entry point for all the backend APIs in our application. API gateway is going to act as entry point for backend APIs. That means here UI application will be available. UI is a separate Angular project or React project. When customers are accessing the UI application, the UI application will communicate with the API gateway and API gateway will send the response back to the UI. So from the UI application, how the request will come to the backend application? Through API gateway. API gateway is a entry point for our backend microservices. If UI application cannot access our microservices directly, that's not possible. If any request coming to our application, first that request should go to API gateway, then API gateway will validate that request. Is it valid request or not? Is this request we need to accept or not? That kind of checks, request checks will happen at the API gateway. If request is valid, then only API gateway will forward that request. If the request is invalid, API gateway will reject the request. API gateway is like a security guard. So it will check ID. Suppose if you go to any company, security guard will be available. They will check ID. If ID is valid, they will open the gate. If ID is not valid, they will not open the gate. Same thing. API gateway will act as a security guard for our backend microservices. API gateway is an entry point for the microservices. So we can validate our request by using API gateway. It is going to act as a mediator between front-end application and back-end APIs. API gateway is going to act as a mediator between our front-end application and our back-end APIs. So in the API gateway, mainly we are going to write a filter to verify the request is valid or not, and routings we are going to write. Filter is used to perform some pre-processing and post-processing. This request is valid or not, we are going to check by using filter. If the request is valid, then forward the request to the particular backend API. For that, routings will be available. If the request is invalid, then we will send error response back to the client. So client is sending a request through UI. The request will go to API gateway. It is our front controller. It is entry point. It is a mediator between incoming request and backend API. So in the API gateway, we will write a filter to validate the request. If the request is valid, then process. If the request is invalid, don't process. So when the request is valid, that request should go to which API? That's where routings concept comes into picture. So inside the API gateway, we are going to implement filters plus routings. Filters will be available and routings will be available in our API gateway. filter to verify whether that request is valid or not. If the request is valid, then it should go to which microservice in the backend. It should go to which API in the backend, that we will configure by using routings concept. So API gateway is a mediator between our front-end application and backend microservices. So this is microservices architecture. In this 2 days workshop, I am not going to cover Kafka and Redis. Time is not sufficient. These are two things I am not covering in this 2 days workshop, guys. The remaining everything I am going to show you in these 2 days of time. DB integration also I am not going to do. These 3 things I am not going to cover in these 2 days. Very clearly I told you what is the agenda for these 2 days. So these concepts we understood. Theoretically we understood these concepts. Now in the tomorrow session, we are going to develop a project by using all these concepts, whatever we have learnt theoretically today. So in these 2 days, I'm not covering Kafka, I'm not covering Redis, I'm not covering DB integration. So in the upcoming sessions, we will plan these also as weekend workshops. The remaining part, whatever the agenda I have given, that I'm going to show you tomorrow practically by developing one project. Are you clear? Are you clear with my point? So in the real time, we are going to use Kafka also for our applications. Our microservices will use Kafka for a distributed streaming. Our microservices will use a Redis server for caching, and our microservices will communicate with the database to perform the operations, CRUD operations. So this is, some companies are going to follow this kind of microservices architecture, but it's not mandatory. Some companies may not use Kafka. Some projects may not use Kafka. Some projects may not use Zipkin. Some projects may not use API gateway. It depends on their choice. I told you before starting this microservices architecture, there is no fixed architecture for the microservices. There is no fixed architecture for the microservices development. We can customize this architecture according to our project requirement. As part of this architecture, we are going to use some components. All the components are not mandatory. We can use them based on the demand. What are them? What are those? Service registry, admin server, Zipkin, config server, Kafka, Redis, Feign client, API gateway. Okay, what is service registry? It is used to maintain all the API's information at one place. It will provide user interface to get the information. What is admin server? It is used to monitor and manage all the APIs at one place. Okay, it also will provide the user interface. Then what is the Zipkin server? It is used for distributed tracing. So how much time it is taking to process our request, that can be understand by using Zipkin dashboard. Config server, it is used to make our application loosely coupled with the configuration properties. Feign client, it is used for inter-service communication. Then what is API gateway? API gateway will act as a entry point for all the backend APIs. It acts as a mediator between our front-end application and backend APIs. So inside the API gateway, we will write the filters and routings. Okay, we can perform pre-processing and post-processing by using filter, and by using routing, we can forward the request to particular backend APIs. Okay, this is all about microservices architecture that people are going to follow. Now, theoretically, we are clear. We need to implement this practically in the tomorrow session, tomorrow morning at 8 o'clock. Tomorrow 8 to 10:30 or 8 to 11, we are going to complete this project development. That is our mini project development. Whatever I have promised for these 2 days. Today's session, theoretically, I have explained what is microservices architecture, what are the advantages and what are the challenges, what architecture people will follow, what components will be available in the microservices architecture. In the tomorrow session, we are going to implement this architecture practically. I hope you got some clarity on what is monolithic, what is microservices, what are the advantages, what are the challenges, what is the architecture. Theoretically, I hope you got some clarity. 50 to 60% clarity you got. Tomorrow you will get the 100% clarity, because we will develop everything in the live class tomorrow. Okay, I hope this class is useful for you. Same Zoom link you can use tomorrow also to attend the class. Tomorrow at 8 o'clock, the session will start. 8 to 10:30, the session will be there. We are going to complete this project development in the tomorrow session. Thank you, all of you. Same Zoom link you can use tomorrow also. In another 10 minutes, I'm going to share these notes and these diagrams in our WhatsApp channel. So this is our WhatsApp channel link. So just open the channel link and follow us. WhatsApp channel link I have given in the chat box. This class notes, this class video, I will share in that.